Okay, we're ready for worksheet 4D for the Math 4 course. Yeah, I think we all can identify with this at some level. All right, numero uno. We are supposed to find x. Well, solve the triangle, but find x first. So let's see, that would be, it is probably more helpful if we put letters on this. So we will try and find little a squared equals b squared plus c squared minus 2bc times cosine of big A. All right, and then we go to plug in. Little a is 16. Little b is 8 squared. Little c is 22 squared minus 2 times 8 times 22 times cosine of A. So 16 squared is 256. 64, 484. That's going to be 44 times 8, which is 352. And then we get to subtract. This becomes a calculator issue. 256 minus 64 minus 484 becomes negative 292 equals negative 352 cosine A. So when I divide both sides by negative 352, I get 0.8295 roughly equals cosine of A. And so A is going to be second cosine, second answer, 33.9, might as well say 34 degrees. So that is my first one. Now we can play the same game. Let's see, did I? Yes, I did. We can play the same game with angle B. We really only have to do this twice, because we can subtract from 180 for the guy that's missing. So if we're going after angle B, we're going to say b squared equals a squared plus c squared minus 2ac times cosine of big B. And so little b is 8, and little a is 16, and little c is 22. Then 2 times 16 times 22 times cosine of b. So now we're saying 64 equals 256 plus 484. 44 times that is 440. 44 times 16 in the calculator is 704 cosine B. So now when we say 64 minus 256 minus 484, negative 676. I didn't think that would be small. And divide both sides by negative 704. I get about 0.96 equals cosine B. And so I say second cosine, second answer, and I get 16.2. So B is about 16 degrees. Now, if B is 16, and we said that A was 34, then all I have to do is say 34 plus 16 plus C equals 180. And C, I'll see that would be 50. That's going to be 130 left over. And I say approximately because all the rest of these were rounded figures. So that's going to make this the product of a rounded figure, calculations with rounded figures. All right, there's number one. Number two, all we have to do is find angle C. So we're going to use this formula. Cosine of big C. And then we'll plug in what we've got. Little c is 7. Little a is 8. Little b is 6. And cosine c is what we don't know. So we're going to say 49 plus 64 plus 36 minus 2 times 8 is 16. 16 times 6 is 96. And if 64 and 36 is 100, we subtract 49 minus 100, we get negative 51 as a result. And then when we divide both sides by negative 96, negative 51 divided by negative 96. And we get 0.53125. All right, so when I punch in the second cosine, second answer, you get 57.9. C is about 58 degrees. All right, you want to attend a bonfire tonight, but you want to stop for a burger on the way. How far are you from the bonfire right now? So you know that it's a mile from you to the fast food and 2 miles from the fast food to the bonfire. Now there's a 54-degree angle happening there. And what you want is this part right there. Now, again, labeling this in terms of A and B and C, and this is little b. So we're going to use little b squared equals a squared plus c squared minus 2ac times cosine of big B. And then we plug in the players that we've got. This is the one we don't got. Little a is 2. Little c is 1. Well, this ought to be pretty easy to cook up. So when I punch that in the calculator, I get 2.64 for b squared. And remember, you're not done yet. When I take the square root of that beast, I get 1.6275. So it is about 1.6 miles directly from you to the bonfire. All right, surveyor measures the distance across the river to 2 different trees. Now, this is your classic side angle side kind of setup for this. If I'm going to label this for convenience sake, then I am looking for little a. So I'm going to say a squared equals b squared plus c squared minus 2bc times cosine of big A. Now, I can plug in b squared would be 100 squared C squared would be 75 squared, minus 2 times 100 times 75 times cosine of 32 degrees. So I should be able to punch all of that in and get a decimal. And so what I get is 2904 and some change. Now I still have to square root that. Second square root, second answer. And I get 53.89, or I might as well call it about. Well, they didn't say where to round it. And everybody up there is a whole number. So I'm going to say it's about 54 meters. Okay. Couple more to go here. Solve the entire triangle. So I got 2 of those. And I got 2 of those. Okay. So we're going to go after big A first. Formula is going to look like that. We're going to plug in 10 squared equals 12 squared plus 16 squared minus 2 times 12 times 16 times cosine of big A. That's 100. That's 144. That's 256. Let's see now. 24 times 16 is 384. Cosine A. Now 144 and 256 add up to make 400. So subtracting 100 minus 400 is going to leave me with that. And then divide both sides by 384. Is going to give me this kind of a decimal. And when I do second cosine, second answer, I get 38.6, which is about 39. So 1 down, 2 to go. The good news is we only have to do this one more time, and then we can subtract from 180 for the odd man out. All right, so we had A equals 39. Now let's chase after B. Cosine of big B. So when I start plugging these in, 12 squared equals 10 squared plus 16 squared minus 2 times 10 times 16 times cosine of B. That's 144, that's 100, that's 256, that is 320. And by the time I say 144 minus 100 minus 256, I get negative 212 on this end. And when I divide both sides by negative 320, I get this for a decimal. And when I say second cosine, second answer, at 48.509, that's going to cause me to round up. That's going to call it 49. And so if A is 39 and B is 49, I should be able to say 39 plus 49 plus C equals 180, which means that C, let's see, that's 88 together. That's going to leave me with 92. Yes. And so we have our all three answers. We already had the three sides, so we just needed to find the three angles. All right, number last, solve the triangle. So what we're going to, well, let's see now. We have angle C is 52, little a is 65, little c is 50. And so what we should, this is a curious use of it, because we have big C and little c. What we're missing is little b. Now let's see how that plays out. If I have big C and little c, then I'm going to say that c squared equals a squared plus b squared minus 2ab times cosine of big C. Now we know, let's plug in what we've got. This is going to turn out a little different from what we've been doing. That's 50 squared and 65 squared, and I don't know squared, equals minus 2 times 65 times b times cosine of 52. All right, so that's going to be 2,500. Let's see, 65 squared is going to be 4,225. Now, if I have 2 times 65 times b times cosine of 52, the only unknown there is b. So I should be able to say 2 times 65 times cosine of 52. That's going to give me 80.035. That's about 80 b. Oh, I hope you see where this is going. I'm going to have a b squared, and I'm going to have a b term, and I'm actually going to need to subtract this 2,500 over here. I'm going to do this manually so that y'all can see where this is going. Now let's see now, 4225 minus 2,500 is 1725. Now, at some point, I'm going to need to figure out what is, how can I factor this beast? Because if I come over here and I do 1 times 1725, well, I usually double it and cut this in half. I'm looking for factors of 1725 that add or subtract to give me 80. And so, but I do know that 5 is going to be a factor here. So I'm going to multiply that by 5. I'm going to divide by that by 5. 22, and I can do it by another 5. 5 will go into that. 6 times with 9. Now, do I have an 80 yet? Not really. There's a 3 that I could pull out of that. 3. And 3 will go into that 23 times. Now, we're not exactly at 80 yet. I'm probably looking for 2 numbers that would add to make this. What if I took this guy and said, let me pull 3 out of the 345, and 3 will go into that 1 and 1 and 3. That's not exactly 80 either. Well, if nothing else, I can go to Desmos and graph it and see where it crosses. All right, so here's what I did. I went to Desmos. Oh, good grief. Now I can't find, wait, now there it is. Okay, there's Desmos. And I plugged in the equation y equals x squared minus 80x plus 1725. And there's a small problem here. Notice that the graph does not cross the x-axis. The graph does not cross the x-axis. What does that mean? That means that if there were any real solutions to this thing, they would be wherever the parabola crosses the x-axis. And because it's not crossing, that's because there are no real solutions to this thing. So the problem is going to be that there is no real solution to this. I'm going to take a moment to sit here and look at the numbers and make sure that I haven't done something. Everything appears to be in place. There's A, there's cosine of C. Now let me double check on something here. 2 times 65 times cosine of 52 gives me 80. So I'm going to be subtracting 80b. When I subtract the 25 over to this side, yeah, there is no solution to this answer. And that's the thing, is that what they're basically telling you is that those numbers cannot exist in that order. Something about the 65 and the 50 and the 52-degree angle, it just can't exist that way. So I guess we're done with that. I guess what this does is this can prove to us that some of these don't necessarily have a real solution in the real world. And we'll end there.